Welcome to ERC TipsKnowLogy. We will be talking about the 8051 microcontroller. In particular, we'll talk about what's inside the computer, internal organization of a computer, microcontroller itself, embedded processors, 8051 family, bus, what's inside the 8051, personal computer, ROM, RAM, data types, registers, ports, pin, block diagrams, machine language, low-level language, high-level language, assembler, C, and compiler. In this first part, we will know what's inside the computer and what are the important terminologies. For example, talking about the unit of data size, we have what we call as the bit, represented by small letter b. It is a binary digit that can have the value 0 or 1. A byte, or capital B, is equal to 8 bits. Therefore, if you have 1 byte, that's equal to 8 bits. 2 byte, therefore, 2 bytes means 16 bits. Next is nibble. It's half of a byte or half of 8 bits, so that's 4 bits. And a word consists of 2 bytes or 16 bits. The terms used to describe the amounts of memory in a computer and its compatible IBM PCs. By the way, IBM stands for International Business Machines, and PC means personal computer. And when we say compatible, it means similar to this kind of computers. Kilobyte, KB, is equal to 2 to the power of 10 bytes. If calculated, it would be over 1000. Megabyte, MB, is 2 to the power of 20 bytes, or over 1 million. Gigabyte, GB, is 2 to the power of 30 bytes, or over 1 billion. And terabyte, or TB, 2 to the power of 40 bytes, or over 1 trillion. The internal organizations of computers. First, let's talk about the CPU. CPU stands for Central Processing Unit. This executes information stored in memory and is the most important part of a computer because it serves as the brain of the computer. When you say I/O, it means input output, and when you say I/O devices, this means the devices that provide a means of communicating with CPU. Memory can be random access memory or RAM. This is a temporary storage of programs that computer is running. The data is lost when the computer is off. So when you turn off your computer, the data inside the RAM will be erased. ROM or ROM, read-only memory. It contains programs and information essential to the operation of the computer. The information cannot be changed by use and is not lost when power is off. It is also known as non-volatile memory or non-volatile memory. In other words, the RAM is called volatile memory while the ROM is called non-volatile memory. Peripherals refers to the monitor, printer, keyboard, mouse, speakers, or anything connected to your computer. Inside the computer, this is the block diagram. We have the CPU, memory, and peripherals connected through the address bus and data bus. Although there's another bus here which is called control bus for the read and write signals. And then we have also here the internal organization of computers, which showing you a more specific block diagram. We have here the CPU again, and the memory now. We have the RAM and the ROM. You will notice that the arrowheads used for the RAM can be an input or an output. Whereas in the ROM, we can just read the data from the ROM. That's why the direction is only going towards the data bus. We have the printer. that receives the data to be printed. That's why it's going into the printer. And for the disk, it can be read or written. That's why the arrowheads are going in and going out. The monitor, we give the monitor what it will display. That's why it's an input from data bus to the monitor. But of course, the monitor is an output device. But the output device or the data that it is displaying will come from the data bus. That's why this arrowhead is going to the monitor. And of course, we have the keyboard where we write our information. Now, you will also see that this is the address bus and this is the control bus. So the read and write signals will be through the control bus. The address bus contains the addresses of all of these devices. Now the CPU is connected to memory and input-output with the use of wires or strips of wires, which we call as bus. This bus carries information from place to place. We have here the address bus, where the CPU puts the address on the address bus and the decoding circuitry find the device. For a device memory or input-output to be recognized by the CPU, it must have an address, and the address assigned to it or to this given device must be unique. It means that it's the only one with that particular address. Another bus is what we call as the data bus, and the CPU either gets the data from the device or sends the data to it. So as you can see, the data bus contains the data, and the control bus provides the read or write signals to the device to know or to indicate if the CPU is asking for information or sending it information. So these are the three buses for the CPU to be used. Now moving on, let's talk more about the data bus. Take note that the more data buses available, the better will be your CPU. And think of the data buses as highway lanes. More data buses means a more expensive CPU and the computer. The average size of data buses in CPU varies between 8 and 64. And the data buses are bidirectional. Bidirectional means it can receive or send data. The power or the processing power of a computer is related to the size of its buses. More about address bus. The more address buses available, the larger the number of devices that can be addressed. The number of locations with which a CPU can communicate is always 2 to the power of x, where x is the address lines, regardless of the size of the data bus. So, if a CPU has 24 address lines and 16 data lines, can provide a total of 224 or 16 megabytes of addressable memory. Each of these locations can have a maximum of 1 byte of data, since all general purpose CPUs are byte addressable. Remember that 1 byte is equal to 8 bits. And the address bus is unidirectional. So it only has one direction. What's the relationship of the CPU to RAM and ROM? For the CPU to be able to process information, the data must be stored in RAM or ROM, which are known as primary memory. The ROM provides information that is fixed and permanent, and examples of this are tables or initialization programs. The RAM stores information that is not permanent and can change with time. Example, various versions of operating systems and application packages are being stored in the RAM. Upon booting, CPU gets information to be processed first from RAM or ROM. If it is not there, then it seeks it from a mass storage device, which we call secondary memory. So the primary memory consists of the ROM and the RAM, while the secondary memory refers to mass storage device. Take note that mass means like big or huge. So we can transfer the information to RAM from these devices if it is not in the ROM. What you see here is the internal block diagram of a CPU. Here, the biggest of the boxes or the block diagram here is the ALU. It means arithmetic logic unit connected to the flags. And we have here the internal bus. As you can see, the program counter is connected to the address bus, instruction register. We have the instruction decoder, timing and control, which is connected to the control bus. We have the data bus, which is connected in the backbone here of the internal buses. And we have the registers A, B, C, and D. This is the internal block diagram of a CPU. Inside the CPU, we have what we call as the register. And the registers, we will talk about it now. The CPU uses the registers to store information temporarily. Remember that the register is inside the CPU. Examples of the information that we store temporarily to the register are values to be processed or the address of the value to be fetched from memory. In general, the more and bigger the registers are, the better your CPU will be. Now, the registers can be 8-bit, 16-bit, 32-bit, or 64-bit. The disadvantage or bad thing about the register is that if you have a more and bigger registers, then it will increase the cost of the device or of the CPU. ALU stands for Arithmetic Logic Unit. It performs arithmetic functions such as addition, subtraction, multiplication, and division. And it also performs logic functions such as AND, OR, and NOT. PC or program counter points to the address of the next instruction to be executed. As every instruction is executed means run. When the instruction is run, the program counter is incremented to point to the address of the next instruction to be executed. In other words, the program counter value will be added with a value to point to the address of the next instruction, or it will be increasing. Instruction decoder. This interprets the instruction fetched into the CPU. Take note that the CPU is capable of understanding more instruction requires more transistors to design, home automation, networking, and entertainment lab. So if you want a better CPU, a more capable CPU of understanding more instruction, then we will require more transistors for it. Thank you so much for this first part of the presentation about 8051 microcontroller. Please subscribe, like, and share this video towards our 1,000 subscribers. Thank you.